This is day 2 notes. I'm only going through the first 2 or 3 pages so that we can spend most of the time in class going through a problem. So in this case, we discussed about earlier about a couple of the things, but there's one couple of things that I wanted to include into this note. So in this one, it says a statement. What is a statement? A sentence that is either true or false is defined as a statement. And this is called the true value of the statement. So whenever somebody is making a statement, we have to say, oh yeah, that's a true statement or that's a false statement. And when we try to figure out whether it's true or false, that is the true value. When we're doing the conditional statement, in last class, you guys remember we did represent it using letters such as P and Q. If there's a third one, there will be an R. So an example would be if P is supplementary angle, angles have the sum of 180 degree. So you know always by the definition, supplementary angle always have 180 degree. So you can say, oh, this is a true statement. So we will just, the true value of this statement will be true. We talked about negation in the previous section in last class. So negation is a statement that has an opposite true value. So if I say negative, it's the opposite. The symbolic notation is this wiggly line, and we can read it as not P or not Q, whatever they gave us. If I put in not P, supplementary angles do not have a value of sum of 180 degree, and that would be false because they do. If we say yes, they do here, if I add a not, and then it has to be not true. So this is the two statements that I want you guys to know. I know you learned it in English class, but it comes back again here in geometry. Our compound statements, when we connected it with conjunction and disjunction. So what is a compound statement? Two or more statements joined by words and or, okay? If I connected with and, or I connect the statement with or, it's called a compound statement. Statement joined by and, the symbolic notation is this, then the true value of it both have to be a true statement. And this is usually if your parents say you have to clean up your room and wash the dishes, they expect you to get both of them done, right? So for them to be happy, or for them to, especially if they put in, if you want to go outside, make sure you clean your room and wash the dishes, they expect you to get both done before you can go outside, right? But if they connect their statement with disjunction, that means they use or, and this is the symbolic notation, and at least one of them has to be true, okay? If they said, if you want to go outside, clean your room or wash the dishes, they give you a choice. You can do both if you want to, but you can just go ahead, do one, and you can go out, right? So those are the things that you have to consider when we're doing disjunction. Disjunction, at least I needed one to be true, but conjunction, or when I connect to statement with and, I need both of them to be true. All right, so these are a couple of examples how we write them down. And every time you're given a statements like this, P, Q, R, just before you even connect them and try to find the true value of them, just make sure, is this statement true? So given the statement below, write a compound statement, then determine their true value. So this one says there are 7 days and 7 weeks. Is that true? Yes, so that is true. March has 30 days. That is false. March has 31st days. Halloween is in October 31st. That is always true. So you put true there. So now when I'm connecting it, P and Q, I'm connecting P and Q, this two statement. So I write it as there are 7 days in a week and March has 30 days. So since it's connected by and, for it to be true, both have to be true. Since this is false, I'm going to say, oh, the statement is going to be false, okay? Because this one of the statement is false, okay? That's something you guys have to remember. This is going to be false. But if we come to connecting it with, all of this are connecting it with and. If I had connect this with or, since one of them was true, it would have been true. But the main thing I want you guys to remember is, how do you connect it? When you see this V, it means or. When you see upside down V, or it looks like an A, it means and. Okay, those are the examples that I want you guys to get to know. My honors class will get into a little bit in depth about writing our truth table, but regular class, all this is all you guys have to know. So now we're gonna flip to the next page, which is this page for the regular honors. I know you have an additional page, so we'll do that in class. So now we're going to deal with Unit 2, Day 2, which is deductive reasoning. Remember, Day 1 was inductive reasoning, but today we're going to do deductive reasoning. And our learning target is I can determine whether the argument is valid or not. I need this time so that I'm not passing my time. Valid, whether an argument is valid or not. Okay, so there are three laws we're going to follow in this case. The following examples show how inductive and deductive reasoning is differ. So they give an example here. Notice that all of her friends at her lunch table all brought their lunch to school on Tuesdays. She reasoned inductively that her friends do not like what is served in the cafeteria on Tuesday. This reasoning is based on a past observation. So every time she sees her friends on Tuesdays, they bring lunch. So she assumed, or inductively, by looking at the pattern, that they don't like the cafeteria food on Tuesdays. Evelyn is taller than Joseph. Joseph is taller than Cindy. Evelyn reasoned deductive that she is taller than Cindy, right? You look at what is the fact, right? Evelyn is taller than Joseph, and Joseph is taller than Cindy. So Evelyn, if Evelyn is taller than Joseph and Joseph is taller than Cindy, then Evelyn is going to be taller than Cindy. This is done by based on acceptance statement. So based on the statement that we know who is taller than the other. So this kind of reasoning is called deductive reasoning. And one of them is called the law of detachment. The other one is law of syllogism and the law of contrapositive. So the law of detachment is really used a lot at home with your family. And for this to be valid, it has to follow the statement. Okay, that's something you guys have to make sure. So if P and Q is a true, and then P is true, then Q would be true. Okay, then Q will be a true statement. So I'm trying to get this pen to work, but it's not writing. All right, let me get. You're not writing today? Okay. All right, so I'll use my mouse. So the symbolic notation is given here. In this case, it's given in this part. All right, all right, so in this case, P is true, and a lot of times this is your parent statement, what I just told you earlier. If you wash the dishes, then you can go outside. Then you went ahead, wash the dishes, that means you can now go outside. So that kind of reasoning, P, Q, P, then Q will be the conclusion, is called law of detachment. So to put it in an example, if you get a part-time job, that is going to be your P, then you can buy a new bicycle. This is Q, okay? Then Roger gets a part-time job, that is P, therefore Rogers buy a new bicycle, that is Q. So when I'm going through the reasoning like this, is called law of detachment, okay? All right, the next one is the law of syllogism. This is if P then Q is true, then Q within R is true. Then since these two are the same, see how P, Q, Q are the same, Therefore, P is in R. And usually I use circles like this. P is in Q, okay? And Q is in R, so the big circle is R. Therefore, P is in R, okay? So that's the statement that we can make. So in this case, it says, and it kind of helps if you kind of color coded it if you want to, but if you don't want to do that, that's fine. So here is if Bill pitches, then Tom will play. So here is Tom plays first base. You see how those two are the same? Then you can say Ed, I want this to be, and Ed catches, right? That's what we see. So every time you have Tom will play first base repeated, the Q repeated, then your statement would conclude by what this is going through, by what this statement. Bill pitches, then Ed catches, okay? That statement is called law of syllogism. If P is in Q, Q is in R, since those two are the same, your conclusion would be P is in R, because anything in P is also in the bigger circle, okay? And the last one is law of contrapositive. If P and Q is true, okay, not Q is true, then not P will be true, okay? So every time you set, this is just like a contrapositive statement, P, Q, not P. So if that's what happened, and that's the conclusion you can come. So every time you see that kind of reasoning, it's called a law of contrapositive. So in this case, the example is if Bree is the set designer of the play, then Tim will paint the, I need to move this, will paint the sets, right? Tim did not paint the sets. So they took the statement and negated it, right? This is not Q. This is not Q. This was Q, but this is not Q. Then your conclusion would be not P. Beer is not the set designer of the play. Okay, so when you see this kind of reasoning, it's called law of detachment. So we'll go through detailed notes on this next class in terms of doing examples. Is it logically, it has a valid argument or not? We'll deal with that. Not all deductive arguments are valid. Use a logical symbol to find the following argument. So if I wanted to do this, I have to, each one of them, I have to kind of say, okay, this is, if you get a part-time job, that's my P, right? And then you can buy a new bicycle. That's your Q. Carl buys a new bicycle. So this is Q. PQQ, I didn't have any like that, right? So far, if it's either PQP or PQ not Q, or that's or there was another statement here, but since I don't have this is going to be not valid. Okay, so try to do this page if you can. If not, we'll go through it in class step by step, and then we'll add more into it. Okay, all right guys, this is for today.